George, your company is gathering data from the sequencing of human genomes. What information can be gained from doing this?
Researchers around the world, mainly large pharmaceutical companies, need to know who is at risk for the new pharmaceuticals and who is exceptionally not at risk for a particular disease. There are very rare individuals around the world that are resistant naturally to a whole variety of diseases, and you'd like to figure out what it is that makes them, their environment or their genes that make them specifically resistant, and bottle that essentially. So, for example, we've discovered individuals who have rare resistance to heart disease, PCSK9 is the gene, or resistant to HIV, which is a great scourge, CCR5 is the gene. And there are things you can do for yourself if you have a disease predisposition. You just don't know it until you get your whole genome sequenced. So basically, everybody needs to see their own genome to find out.
And so how specifically does your technology work in gaining and storing and analyzing this data?
Well, first of all, we do the whole genome, not something called exomes or SNPs, which is medically much more valuable. You retain possession of it. So even when somebody wants to ask a question, they're asking what combination of genes, environments, and traits or diseases pertain to a population of which you're a part. So you're not giving them your genome, even briefly. You're allowing them to answer questions. Or if you want to answer questions about yourself, you don't need to learn, you don't need to see your own genome. You can protect yourself from anything that's not medically actionable by your definition. You can decide in advance what you are willing to share, even in encrypted form.
And so what's the biggest hurdle you see in seeing mass adoption and having this as a regular part of the healthcare system and being able to research and develop drugs and medicine?
Well, I think one barrier that's been eliminated, is no longer a barrier, is the cost. It's now, on the order of $500 cost, but $0 to the individual because of this new Nebula system. Another was privacy and security, which is now solved with this encryption and blockchain methods. People have to hear stories of people that have obtained benefit. It's a little bit like seatbelts. A lot of people had seatbelts, but they didn't use them. There has to be some mechanism by which we improve the public health, even once it's free and safe.
So, George, how long before we actually see mass adoption of human genome sequencing in healthcare?
Well, we're already seeing pretty extensive use among people who have severe diseases and they don't know what's causing it. But everybody is at risk, and you'd like to do it preventatively rather than waiting until the disease is there. So it's kind of like there's no particular day, but there might be a tipping point where we go from the very tiny number of people right now that are getting maybe less than a fraction of a percent to everybody. In the same sense that 1993 was kind of the year that we went from almost nobody having a computer to everybody having some kind of access to the internet.